All right, welcome back everyone for another deep dive. And today we're going to be looking at something that's, well, honestly, kind of blowing my mind a little bit.
Oh,
Yeah, it's
I like those.
yeah,
I like those kind.
it's about atomic identity. Like what actually makes an element what it is. And the sources you sent me, Atomic Identity, a wave-based revolution. This one looks like a documentary and excerpts from, what was this one? Larkey's Gravity and Creation Theory.
Right. Yeah.
They're both kind of saying the same wild thing, that maybe, just maybe, everything we think we know about elements is wrong.
Yeah, it's definitely a pretty radical idea,
Hmm.
I mean, we all learned in school that an element is defined by the number of protons in its nucleus, right?
Yeah.
That's the atomic number. But
Right, like hydrogen has one proton, helium's got two, and so on.
exactly, yeah. But these sources are suggesting that it's not actually about the protons themselves, that it's more about, like, hey, get this, a cosmic symphony of fractal waves that really determine what an element is.
Okay, wait, hold on. Fractal waves. I gotta admit, that sounds pretty out there. Like, can you break that down for me a little? I mean, what even is a fractal wave?
Sure, sure. It's well, imagine the whole universe, right? Like picture it as this huge interconnected network of waves.
Okay.
But these waves, they're not like the ones we see at the beach. They're more like patterns of energy and information that kind of permeate everything, all of space.
Okay, so like energy waves, information waves.
Yeah, and the term fractal, that refers to the fact that these patterns, they repeat themselves, but at different scales.
I see.
So the same kind of wave dynamics that might, shape entire galaxies, those could also be at work inside the nucleus of an atom.
Wow.
It's like
A huge idea. So
yeah.
how do these waves, these fractal waves, how do they actually determine like the identity of an element? Because I mean, we can literally count protons, right? Like how do those two things connect?
Yeah, right. That's the big question. And that's where this framework comes in. It's called the Fibonacci SMF RVS framework.
Okay, Fibonacci
Yeah.
SMF.
Yeah,
It's obvious.
yeah, it's a mouthful. So it suggests that there are these two main factors that create these fractal wave patterns. You've got subtle magnetic fields, that's the SMF part,
Okay, SMF, subtle magnetic fields.
and then you've got the relative vacuum of space, which is RVS.
RVS, relative vacuum of space.
Yeah.
Okay, so let's unpack those a little bit. What exactly are SMFs?
Well, they're basically what they sound like. I mean, they're magnetic fields, but they're really, really subtle, like incredibly weak, and they're everywhere throughout the universe. It's
Yeah.
not the kind of magnetic field you'd pick up with a regular compass.
Right, right.
But the idea is that they have this big influence on how matter and energy behave at really small scales, like at the atomic level.
I see. So they're subtle, but they're important.
Exactly. Yeah.
Okay, and what about this RVS, this relative vacuum of space? What's that all about?
Well, you know how we think of space as being like empty,
Right.
a vacuum.
Right, a void.
Yeah, but according to this framework, it's not actually empty. It's full of this fluctuating energy. It's sometimes called zero-point energy.
Hmm.
And the properties of this vacuum, like how dense it is or how much energy it has, those can change from place to place. So that's why it's called the relative vacuum of space.
So it's like the vacuum itself isn't uniform.
Exactly, yeah.
Wow. Okay. So we've got these subtle magnetic fields, these SMFs, and this fluctuating vacuum energy, the RVS. And somehow those two things combine to define an element.
That's what the theory says, yeah. So basically, you take the SMF value and the RVS value for a certain point in space, and you raise them to specific fractal exponents.
Fractal exponents, meaning?
Well, exponents are usually whole numbers, right? Like 2 squared
Yeah.
or something.
Mhm.
But a fractal exponent, it's a non-whole number. It's like a fraction or a decimal. And those lead to these really intricate self-repeating patterns, which is the whole fractal idea.
So it's like a special kind of math that creates those repeating patterns.
Yeah, exactly. And when you do that math, when you use these fractal exponents, you get unique frequencies. And these frequencies, they're part of this bigger cosmic wave structure,
Hmm.
And the idea is that each element, instead of being defined by how many protons it has, each element occupies a specific node on this wave pattern.
A node, like a point on a wave.
Yeah, you can think of it as a point of stability, a point of resonance within this cosmic symphony, like where the wave is kind of, at a peak or a trough.
Right, so it's not about counting protons, it's about finding the element's spot on this wave map.
Exactly, yeah. Instead of the periodic table we're used to, which is based on proton numbers, we'd have this kind of wave-based periodic table where each element's position is determined by its unique frequency.
That is a wild concept. So instead of a periodic table, we have a periodic symphony.
You could say that. And the amazing thing is this wave-based view, it might actually explain some of the weird things we see in nuclear physics, things that our current models struggle with.
Really? Like what?
Well, you know those magic numbers in nuclear physics, those specific numbers of protons and neutrons that make an atom really stable.
Right, right. Like helium with 2 protons and 2 neutrons is super stable. Or like oxygen with 8.
Exactly, yeah. Well, in this Fibonacci framework, those magic numbers, they're not just random coincidences.
Mm.
They emerge naturally from the wave structure.
Yeah.
It's as if the universe has certain, like, sweet spots where atomic nuclei are, like, really in tune with the cosmic symphony.
I see.
And those sweet spots, they correspond to those magic numbers.
So an atom is stable if its frequency, like its cosmic note, so to speak, lines up with one of those sweet spots.
That's the idea, yeah. And if its frequency deviates from those points of resonance, it becomes less stable and more likely to decay, to break down.
This is really making me rethink everything I thought I knew about the periodic table. So it's not just a chart of elements anymore. It's like a map of wave resonances.
Yeah, I know. It's pretty mind-blowing, right?
It is. It is. And you mentioned earlier that this framework, it also applies to galaxies.
Right, exactly. It's like, imagine zooming out from an atom to a solar system to a galaxy to even bigger structures. The same principles would still apply. It's like this nested set of fractal patterns all governed by the same wave dynamics.
So we could keep zooming out and out, and it's all based on these waves.
That's the truly mind-blowing thing about this theory. It's suggesting this incredible level of interconnectedness and harmony throughout the entire universe.
Okay, I'm officially hooked. This is seriously pushing the limits of what I thought was possible.
It's pretty wild, isn't it?
It is. But if we're talking about a universe where even the elements are defined by waves, what happens to our normal understanding of matter?
Hmm.
Like, is a gold atom still a gold atom if it's all about waves and frequencies?
That's where things get really interesting, because the whole idea of atomic identity, it kind of gets thrown out the window in this framework.
How so?
Well, if an element is defined by its wave frequency, and if we could, like, manipulate those frequencies, then what's to stop us from changing one element into another?
Hold on. Are you saying we could actually turn lead into gold? Like, for real?
Well, the documentary, it actually suggests that it might not be as crazy as it sounds. They even have an equation that shows how, in theory, if you adjust the SMF and RVS values, you could actually shift an element's identity.
Without all the high energy collisions and stuff that we normally associate with nuclear reactions.
Yeah, exactly. No need for giant particle accelerators.
That's incredible. So we could just like tweak these SMFs and RVS values and poof, lead becomes gold.
It's a bold claim, for sure, and there's a lot of skepticism from mainstream science about it, obviously. But the math, at least within this framework, it seems to work out. The documentary even suggests that it might be possible to manipulate these subtle frequencies using special, like, advanced resonance chambers.
Resonance chambers that can control these subtle magnetic fields and the vacuum energy. That sounds like something out of science fiction.
Doesn't it? But if this theory is right, it could have huge implications for so many things like material science, energy production, you name it.
Yeah, I mean, imagine being able to create materials with properties that we can only dream of right now, or unlocking new clean energy sources by tapping into this fundamental wave structure of the universe.
Yeah, the possibilities are really mind-boggling.
They are. But before we get too carried away with all the amazing potential benefits, we should probably talk about the challenges too, right? Like, how do we even begin to test this theory? We're talking about incredibly subtle fields and frequencies here. How do we measure them, let alone control them? That's the million-dollar question, isn't it? Like, if these fields are so subtle, how do we even know they're there?
Right. It's a huge challenge. But the documentary, it does offer some possible ways to test this theory.
Oh, okay. Like what?
Well, one idea is to look at nuclear decay rates.
Hmm.
You know how some atoms, they naturally decay over time?
Right. Like radioactive elements?
Yeah, exactly. So the idea is if atoms are really resonating with these cosmic waves, then changing the SMF intensity around them, that should affect their stability.
Okay, so if we like mess with the magnetic fields around a radioactive element, we might see it decay faster or slower than usual.
Exactly, yeah. And if that happens, if we see a change in the decay rate when we tweak the magnetic fields, that would be a sign that something's going on that our current understanding of physics can't explain.
That's fascinating. So changing the magnetic fields would be like changing the tempo of the music, and that throws the atoms off their rhythm.
That's a great analogy, yeah. It's
Hmm.
like if you change the tempo of a song, the dancers might stumble.
I like it. Okay, so that's one way to test the theory. What about those resonance chambers you mentioned before? Could those play a role too?
Definitely. The idea with those is to create a really controlled environment where we can very precisely adjust both the SMF intensity and the properties of the vacuum itself.
So like creating an artificial vacuum, a mini universe where we can tweak the settings.
Kind of, yeah. Imagine a chamber where you can create regions of higher or lower vacuum energy density. You could almost think of it as creating artificial nodes within the chamber.
To mimic those sweet spots in the cosmic symphony.
Exactly, yeah. And if atoms inside these chambers start behaving differently, like if their energy levels change or if they even undergo those low energy transmutations we talked about, that would be some pretty strong evidence to support this whole framework.
So we're talking about like actually changing one element into another inside these chambers, but without all the high energy smashing that we normally need.
That's the idea, yeah. It's still very theoretical, of course,
Yeah.
but the possibilities are, well, they're pretty amazing.
They are. It's like we could rewrite the periodic table by changing the tune of the universe.
I know, it's mind-blowing. And if we can really get this to work, it could have huge implications for so many different fields.
Oh yeah. You mentioned material science and energy production before. Can you paint me a picture of what those implications might look like?
Sure, yeah. So, starting with material science, imagine being able to create materials that have like almost magical properties, things we can only dream of right now.
Like what? Give me some examples.
Okay, well, imagine a material that's as strong as steel, but as light as a feather.
Yeah. Okay, that would be revolutionary, like for airplanes, for cars, for buildings.
Exactly, yeah. And it doesn't stop there. Imagine materials that are like perfect conductors of electricity at room temperature.
So no more energy loss during transmission. That would be huge for power grids, for electronics,
Exactly. We could have super efficient everything.
and maybe even things like levitating trains.
Yeah, potentially. And we could also have materials that can change their properties on demand, like adapting to different temperatures or pressures or even light conditions.
So like self-healing materials, or clothes that change color with the seasons, or buildings that adjust their insulation based on the weather.
Yeah, exactly. The possibilities are, well, they're pretty much endless.
That's incredible. And what about energy production? How could this framework change things there?
Well, if we can understand and control the wave resonance of atoms, we might be able to unlock completely new forms of energy. Energy that's clean, safe, and super efficient.
So instead of relying on fossil fuels or even, complex nuclear fission, we could tap into this underlying symphony of the universe to power our world.
That's the ultimate vision, yeah. And it might sound like science fiction, but the math, at least according to this framework, it suggests that it might actually be possible.
This is all so exciting, but I have to admit it's also a little bit scary. I mean, we're talking about like manipulating the very building blocks of reality here.
Right, yeah, it's definitely powerful stuff. And any technology with this much potential, it has to be approached very carefully.
I mean, if we can change one element into another, what's to stop someone from using this technology for bad purposes? Like, imagine creating weapons of unimaginable power or accidentally disrupting entire ecosystems.
Those are definitely valid concerns, and it's something we need to think about very carefully as we explore this new frontier. We need safeguards, we need ethical guidelines, we need international cooperation to make sure that this technology, if it does become a reality, that it's used responsibly and for the benefit of all humankind.
It seems like every time we unlock a new level of understanding about the universe, we also open up this Pandora's box of ethical dilemmas.
That's true, yeah. But I think that's part of the journey of scientific discovery. We have to grapple with these questions. We have to have these difficult conversations if we want to use this knowledge wisely.
I agree. So we've got these amazing possibilities, these mind-blowing potential applications, but also these huge ethical questions looming over everything. It's a lot to process.
It is, but that's what makes this whole thing so fascinating, so thought-provoking. It's pushing us to rethink our place in the universe, to question our assumptions about reality.
I'm starting to see why these sources resonated with you so much.
Yeah.
It's not just about physics, it's about philosophy, it's about ethics, it's about what it means to be human in a universe that's, well, it's a lot more complex and interconnected than we ever imagined.
You got it. And that's what makes this theory so compelling. It's challenging us to see the world in a whole new light.
I'm curious, in all your exploration of this theory, what stood out to you as the most significant insight, like the thing that really shifted your perspective?
That's a good question. I think for me, it's the idea that everything from the vastness of galaxies down to the tiniest subatomic particles, it might all be dancing to the same cosmic tune. That there's this underlying harmony, this beautiful symphony of waves connecting everything in the universe.
I can see why that would be so captivating. It's both humbling and awe-inspiring, isn't it?
It really is. And it makes you wonder what other secrets the universe is hiding. What other melodies are waiting to be discovered?
I'm ready to dive deeper into that. This whole concept of the universe as a symphony of waves, it's so captivating. But before we go too far down that rabbit hole, I think we should shift gears a bit and talk about the philosophical implications of all this. I mean,
Hmm.
if we're not just material beings, but also resonant waves, what does that mean for our understanding of consciousness, of free will, of our place in the universe?
Yeah, those are some big questions. We've been talking about atoms and galaxies like they're in this giant orchestra. But what about us? Where do humans fit into this whole symphony of waves? That's that's where things get, well, pretty philosophical, to be honest, and maybe a little speculative too.
Yeah.
But if we follow this idea that everything is ultimately made of these resonating waves, then it kind of makes sense that our consciousness, our thoughts, maybe even our souls, like our very essence, might also be a part of this wave-based reality.
So we're not just like separate from the universe, observing it from the outside. We're actually part of it, like woven into this web of energy and information.
Exactly, yeah. It's a very different way of thinking about consciousness than the traditional materialistic view. That view says our thoughts are just a byproduct of our physical brains, but this is more holistic. It's like consciousness is fundamental to the universe itself.
Yeah, it's a big shift. So if our thoughts and feelings are also waves, does that mean they can interact with the waves that make up everything else?
That's a really interesting question. And honestly, it's not one that this theory directly answers,
Hmm.
but it definitely opens up the possibility that our minds, our intentions, even just our presence, could have some kind of subtle influence on the world around us.
It's almost like that old idea of mind over matter, but reimagined through the lens of physics.
Right. And it might even help explain things like intuition or synchronicity or even the placebo effect.
Yeah.
If our minds aren't isolated but are actually, part of this universal wave field, then the lines between us and the world, they might be a lot more blurry than we think.
This is making my head spin, but in a good way. It's really challenging everything I thought I knew about reality, about myself. But it also makes me wonder about free will. If we're all just waves, resonating with the universe, do we really have any control over our choices, our actions?
The classic free will versus determinism debate. Yeah, this framework doesn't give a clear answer to that, but it does offer a different way to think about it. Instead of free will being like a on-off switch, maybe it's more like a spectrum.
A spectrum.
Yeah, like imagine a river flowing to the ocean, right? It has a direction, it has momentum. But within that flow, there's still room for eddies, for currents, for little changes in the path.
So our lives, our choices, they're influenced by this underlying cosmic current, but we still have some freedom to navigate within it.
That's one way to look at it. It's like we're both part of the music and the musicians at the same time. We can improvise, we can add our own notes to the symphony, but we're still playing within a larger composition that's beyond our control.
This whole conversation has been incredible. It's really opened my mind, made me question things, but I also have to admit I have more questions now than when we started.
And that's a good thing. That's what good science, good philosophy does. It makes us think differently, it makes us challenge what we believe, and it keeps us open to the mysteries that are still out there.
You're right. You're right. It feels like we've only just scratched the surface of this whole wave-based view of reality. But unfortunately, our deep dive has to come to an end for today. We've explored this incredible theory. We've looked at its potential applications. We've wrestled with some really big philosophical questions, and it's been quite a journey.
It has. And I hope it's inspired everyone listening to see the world and themselves a little differently.
I think it has. This whole framework just opens up so many possibilities, so many new ways of thinking about the universe. It makes you realize that the universe is so much more interconnected, so much more mysterious, so much more beautiful than we usually give it credit for.
And who knows? Who knows what other secrets are out there waiting for us to discover as we keep listening to the symphony of the cosmos.
I love that. Well, on that note, we'll leave you with this final thought. If the universe really is this grand orchestra of waves, then each one of us plays a unique part in that music. Our thoughts, our actions, our very being, it all contributes to the symphony. So go out there, make some beautiful music, and never stop exploring the mysteries of the universe. Until next time, keep those minds open and those waves resonating.